Assalamu alaikum. I'm Samia Jamil, and my group members are Ahmed Fazal and Mahnur Rashid. Our topic is speech emotion classification using machine learning and deep learning. Next slide. Our topic includes problem statement, introduction, methodology, results, and future work. So basically, in this, we have to classify emotions of an individual through speech recognition using machine learning and deep learning algorithms. Next. So the first one is a speech recognition. In the context of computer science, the process of enabling a computer to identify and respond to the sounds produced in human speech is basically speech recognition. And speech emotion recognition is basically to recognize the emotion from speech and then classify emotions that from which class it actually belongs. And using machine learning and deep learning algorithms, we need pre-processed data and a model for classification. Next. So the algorithms of machine learning which we used in our project is sport vector machine, random forest, and Decision tree. And the deep learning algorithms include CNN, MLP, and VGG16. The next slide. So the dataset which we used is RAWDIS, and it contains audio samples of 12 male and 12 female artists, and that is further labeled as 8 classes in which we are going to classify our data. These classes are shown as happy, sad, afraid, furious, disgust, surprised, and neutral. And further about the dataset, Ahmed will explain about datasets.
So the dataset, as told by Samia, is the RAW-based dataset. It contains a total of 1,440 audio files, which belongs to 24 individuals. 12 of them are males and 12 of them are females. And each individual has 60 audio files. So the audio format is WAV and with a 68 kilohertz sampling rate. And the entire data set contains no gender bias, which means that there are 50% of males and 50% of females. So I'll move to the methodology in which firstly we prepare the data for processing. We extract the audio files. So we extract data from audio files using the LibRosa library, and the audio files are loaded sequentially, and one by one all the audio files are converted into an array, and the Python array has elements which are the amplitudes of our audio files. So after that, we do some pre-processing on our data, which is that we first trim our audio files, which is that we remove all the blank spaces from the first and the end of each audio file, and then we remove and then we add noise in our data so that we can remove the idealistic characteristics from all the audios and simulate the real life scenarios. After that, we do some feature extraction, and which are 3 of them. And the MEL spectrograph, which is a logarithmic spectrograph converted to the MEL scale. And then we have the MFCC, which is a feature extraction method, which fits all the features on a MEL scale. And then we use Chroma, which is a spectrum of logarithmic frequencies applied to the octaves of the audio files, audio data, and then project the spectrum in 12 bins as a representation of the audio. So this is a flowchart of the methodology. After doing all of that preparation, pre-processing, and the cleaning of data, we classify the data using our ML and DL models. And what we do is that we get all the features of the audio, we tune the pitch of the data, we add some noise in the data, we add some stretch in the data, and we coalesce, we augment all the data into a single NumPy list, and then we train it for 570 epochs for various machine learning and deep learning models. So the results section will be discussed by our group member Mahnur.
Okay, in this section, we will discuss different algorithms of machine learning and deep learning. You have seen about wave plot. When we were not apply any preprocessing technique, the audio file looked like this wave plot. Next, after applying preprocessing techniques, we add some noises, some speed and pitch in the audio file, some stretches in the audio file. The wave plot look like this. Next. We will discuss different techniques like decision tree, random forest, support vector machines, multi-layer perceptron, CNN, and VGJ16. First, the random forest. From the random forest, we get a 69% of accuracy. And this table shows the accuracy according to their categories. Like angry, on the angry emotion, we get 83 precision, 76% recall, and 80% F1 score. And the other categories are happy, sad, neutral, calm, disgust, and fear. The next is MLP. In this algorithm, we achieved about 72.62 accuracy, and these are the emotions and the respective precision, recalls, and FN score. This is the graph which shows the epochs against accuracy of MLP algorithm without preprocessing technique. After we apply a stretch on a data, after preprocessing level, we apply a CNN algorithm. We get the following graph against accuracy and epochs. This is the result after the algorithm of CNN, that the emotion against their precision, recall, and FN score. These is all the algorithms and their results. Like decision tree, we have achieved a 52% accuracy. In the random forest, we get 69%. SVM, sport vector machine, we get 50%. And in the MLP, this is the algorithm, we get a better result against another all the other algorithms. There we get a 73% accuracy. In CNN, we get 42, and the pre-processed CNN is 55% accuracy.
So after all that result section, I would like to conclude our presentation with discussing some future work. So basically, our data set was only limited by the gender field. We wish to use a data set which contains more classes, using which we can, classify our emotions of the audio files. So in this data set, we classified 8 different emotions. We predicted 8 different emotions, and we would like to use the same model for more emotions, for predicting more emotions. And we did not get really good accuracies from our models, and we would like to use a bigger training data set that would improve our models, and then hopefully we would get more accuracies on our data sets in our models. And thank you for listening to our presentation.